my amazing students. This is Mrs. A, and I am here with 9.6 tonight, and 9.6 is dividing radicals. And remember in class I told you that we're not so much dividing radicals as we are simplifying radicals, and one of the major rules of simplifying radicals is that we cannot have a radical in the denominator. So we have to get the radical out of the denominator. With square roots, that's pretty easy. We simplify the radical down as far as we can, and then we multiply by 1 in the form of the radical that is in the denominator. So let's see how that works. So here we have 3 over the square root of 7. The square root of 7 is already simplified, but it's in the denominator, which is a no-no. So we're going to multiply by 1 in the form of the square root of 7 over the square root of 7. And we know that the square root squared is going to give us 7. Square root of 49 is 7. So we're going to get a 7 and a 3 square root of 7 on the top. And that is simplified. So now we have 2 over the square root of 8. And the square root of 8 is not simplified. So we could turn the square root of 8 into the square root of 4, the square root of 2, and the square root of 4 is going to be 2. So this is equal to 2 over the square root of 4, which is going to be 2. So we're going to just simplify it. We haven't multiplied by anything. And now we'll multiply by the square root of 2 over the square root of 2. And then the square root of 2, the square root of 2 is a 2, and that 2 is going to cancel with this 2 upstairs, and we wind up with the square root of 2 over 2. And that is the simplified answer. All right, so now let's look at the next one. We have 10 over the square root of 12, but again, square root of 12 is not simplified. I usually simplify first. So I would make that the square root of 4, the square root of 3, and this square root of 4 is then going to become a 2. So now that I've simplified the denominator, I'm going to multiply by 1 in the form of square root of 3 over square root of 3, which is going to leave me with a 10 square root of 3 in the numerator, and this is 3 times 2 is 6. Now, 10 and 6 should reduce by 2. I don't want to leave anything unreduced, so I'm going to divide by 2, and I'm going to get 5 square root of 3 over 3. And that would be my simplified answer. Remember, something inside the radical does not divide with something outside the radical. And here, in this one, we're going to, since the square root of 3 is already simplified, we're just going to multiply by 1 in the form of the square root of 3, so that I will get 9 square root of 15 over 3. And that is the end of that one, except for 9 and 3 would cancel. So let's go ahead and do that. Let's cancel the 9 and the 3. And now we have 3 square root of 15, and that is simplified. So there's that board. Now we have a variable in the denominator. So we're going to, k is simplified, square root of k over square root of k is k on the bottom, square root squared, and then a square root of k on the top, and I can't do anything to simplify that. On the bottom, now we have our first cubed root. Now, just like a square root squared gives you what's underneath the radical, a cubic root would have to be cubed to give you what's under the radical. So what we do with cubic roots is we just go what do we need to multiply by to get to the next perfect cube? And we know that the cubic root of 8 is a perfect cube. So the cubic root of 8 is what we're trying to aim for to get the radical out of the denominator. So we're going to multiply by the cubic root of 2 in the form of 1. So we're not changing anything. But notice what my denominator goes to the cubic root of 8. And the numerator is going to now be cubic root of 2. And the cubic root of 8 is 2. So we wind up with the cubic root of 2 all over 2. That should be the correct answer for that one. So there's that board. And the next one is 4 times the cubic root, 4 over the cubic root of 3. The cubic root of 3 can get to 27. Remember my cubes. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. So these are goals when we're trying to get to a perfect cube in the denominator. So I'm going to multiply by something that's going to get me to the cubic root of 27 in the denominator, and that something is going to be the cubic root of 9. So I'm going to multiply by 1 in the form of cubic root of 9 over cubic root of 9. And my new denominator is cubic root of 27, that was my goal. And the top is going to be 4 times the cubic root of 9. And lastly, I will simplify this to a 3, and I get 4 cubic root of 9 over 3. Now remember, something inside the radical cannot cancel with something outside the radical, so that is as simple as it will get. Okay, down here, I'm going to go ahead and break this up using my quotient rule. So cubic root of 2 over cubic root of 5. We're going to multiply by something to get to the cubic root of 125. So this is my goal because it's a perfect cube. And I'm going to have to multiply by the cubic root of 25 over the cubic root of 25. And my new answer will be the cubic root of 50. And on the bottom, I get cubic root of 125, which is just 5. So there's a picture of that. And this one is cubic root of 4 over cubic root of 2 over cubic root of 4. If I went ahead, see, neither one of those are perfect. If I went ahead and put these under one big radical, then that's going to reduce to the 4th root. Did I say cubic root? It's the 4th root. And 1/2, 4th root of 1/2, which is the same thing as the 4th root over the 4th root. So now I'm putting it back in 2 separate 4th roots. And then, of course, the 4th root of 1 is just 1. So we'll make that a 1 upstairs. And now we're talking 4th roots. What do I have to multiply to get to a perfect 4th root? Well, 16 is a perfect 4th power. So we're trying to get to 16, so we're going to multiply by the 4th root of 8 and the 4th root of 8. Okay, so when we do that, this one, well, bringing this down, is going to wind up being the 4th root of 8 over the 4th root of 16 is 2. Okay, and so the last one here is the 5th root of y squared in the denominator. Well, I need to multiply that by the 5th root of y cubed to get to the 5th root of y to the 5th. That's what I'm trying to get to. So I have to multiply by 1 in the form of the 5th root of y cubed. And so my answer is going to be the 5th root of y cubed over the 5th root of y to the 5th is just a y. So that is the answer to this one, and this one is the answer to the one upstairs. Picture of that. All right, so now we've got a 5th root of a cubed over b, and notice that there is nothing that I can pull out between an a cubed and a b. So I'm going to go ahead and write this as two separate radicals. So just to save space, I'm going to do it right here in the same spot. So now we've got a 5th root and a 5th root here. And now I'm going to go ahead and only have to deal with the one that's on the bottom. So I'm trying to get to the 5th root of b to the 5th, because the 5th root of b to the 5th would be a perfect root. So I'm going to, or a perfect root of a perfect power, I'm going to multiply by the 5th root of b to the 4th, because those two multiplied together would complete this. And of course, I always have to multiply by 1. So now I've got this in the denominator, which is what I wanted. And now in the numerator, I've got the 5th root, a cubed, b to the 4th. And the only thing I can do to help that situation at all is to go ahead and turn this into the 5th root of b to the 5th is just b. That's all I can do. On the second one down here, we have a 2 minus the square root of 3. Now this is our first problem that has 2 terms in the denominator. And we're trying to rationalize that denominator. And remember, when we have that situation, we're going to use conjugates. So we're going to multiply by 1 in the form of the conjugate of 2 minus the square root of 3. So we're going to multiply 2 plus the square root of 3 over 2 plus the square root of 3. Now, the numerator is going to become 2 plus the square root of 3, but the denominator is going to, when we FOIL this together, remember, when you FOIL conjugates, the inside terms and the outside terms will cancel, and it will leave you with a squared minus b squared, or first term squared minus the last term squared. So the first term squared would be 4, minus the last term squared would be 3, because we have a square root squared. So we should wind up with a 1, but let's just FOIL it just to make sure. We FOIL the first one, we get 4. We do the outsides, we get 2 square root of 3. Do the insides, we get minus 2 square root of 3. And the last, we get a negative square root of 3 times the square root of 3 is a negative 3. So these do go out. We get 4 minus 3, and the answer, when you have 4 minus 3, is just a 1. So I'm just going to erase that and put 1. And of course, since it's just a 1, we can do without that altogether, and the answer is 2 plus the square root of 3. Right, the next one also has 2 terms in the denominator, 2 radicals in the denominator. So I'm going to multiply by 1 in the form of square root of 3 minus the square root of 3, square root of 6, excuse me, and the square root of 3 minus the square root of 6. Now, we just did it on the last one, so I'm not going to do it on every one. The pattern when we multiply by conjugates is the answer will be a squared minus b squared, or the first term squared, which will be 3. Take away the last term squared, which will be 6. So 3 take away 6 would be a negative 3 on the bottom. And the numerator, we're going to end up with a square root of 12 times the square root of 3 is the square root of 36. And then minus the square root of 12 times the square root of 6, which is the square root of 72. So we do need to simplify this sum. So let's just bring this one down a little bit. Okay, so this one is going to be 6. The square root of 36 is 6 minus, now, 72 has 36 in it. In fact, 72 will be the square root of 36 times the square root of 2 will make the square root of 32. So we're going to reduce square root of 72 into 6 square root of 2. So 6 square root of 2 is my reduced answer there. And then on the bottom, I have a negative 3. Now, lastly, the 6's and the 3 are all outside of a radical, and so they will cancel. And we're going to wind up with a what? Negative 2. And then, so we're just going to put our answer right here. Right here. We got a negative 2 right here. And then a negative divided by a negative is a positive 2 square root of 2. Okay, so that's the answer. And we'll get rid of this so we can do our next problem. Okay, the next one has one radical but 2 terms in the denominator. So we're going to multiply this one by 1 in the form of the conjugate of the denominator, 3 plus the square root of 5, 3 plus the square root of 5. So the denominator is going to be the a squared minus b squared, or 3 squared, which is 9, minus square root of 5 squared, which is 5. And the numerator is going to have to FOIL. Okay, so we got the first term is 3. The outside is square root of 5. The inside is 3 square root of 5. And the last 2 is just another 5. All right, so far so good. So now I've got my square root of 5. My 3 square root of 5 is 4 square root of 5. When I add these two together, my 3 and 5 is an 8. And then I'm dividing by a 4. 9 minus 5 is 4. So won't my 4 divide into my 8 and divide into my 4, leaving me with a 2 plus square root of 5. And 2 plus square root of 5 should be the answer for the last one. Okay, so now we have 2 in the denominator again. So we're going to multiply by 1 in the form of the conjugate. So now when we do that, our denominator is going to be a squared minus b squared, or the square root of x squared, which is x, minus the square root of y squared, which is y. And notice, okay, I end up getting this as a denominator. And now in my numerator, I'm going to multiply all this together, but just for the purposes, I'm going to just write it down, because guess what's going to happen? Can you see something nice that's going to happen? We've got the x minus y that we're about to have to distribute. We're not going to have to distribute at all, because we have an x minus y on top and an x minus y on the bottom. We're going to cancel those out, and our answer is going to be this parenthesis right here, which is the same thing as this parenthesis right there. So the answer will be square root of x plus square root of y. End of story. Okay, so now let's look at this one. There is nothing in common with the a cubed and the b, or the 2 with the 5, so we're going to go ahead first thing and split this into 2 square roots. Okay, now we have just one term on the bottom, but that term has a variable. We were dealing with numbers before, and now we have a variable. So we're going to multiply by the smallest. That one is simplified. This is a square root, not a higher root. So we're just going to multiply by the square root of 5b over the square root of 5b. Always by 1, always by 1. The denominator is going to become a 5b. The numerator is going to wind up being the square root of 10 a cubed b. And that one is not going to simplify, because even though this is a 10 and that's a 5, the 10 is inside and the 5 is outside. But I do see something I can simplify. I have this a cubed So I have a perfect square underneath, so I'm going to have to pull that out. Okay, so this top one is going to simplify into 10. There's nothing perfect in 10. A squared will go here. A will go over here in the leftovers, and B will go over there in the leftovers. So in order to fix that, I'm just going to make this a little shorter. Okay, and this square root of A squared is going to come out, be an A. And then this one is now going to be without that exponent. And now that is simplified. All right, so now we have one that has lots of variables underneath it. And there is benefit to keeping this one together because we have T's and we have U's that we could simplify before we split it apart. So let's go ahead and leave it all together for now. And we've got 12 divided by 1, so we'll just keep the 12. We're going to put it all under one big radical. We've got the t to the 4 and the t to the 7 on the top. When I end up simplifying those, canceling those, I get a t3 on the bottom. And we get a u squared on the top. And now we would split it apart, okay? So we're going to go ahead and split this one apart into two separate radicals. So now I'm looking for perfect and leftover. And on this one, perfect and leftover. So on the denominator, we got a t squared and an extra t. In the numerator, we've got a 4 times a 3, and the u squared is perfect. Okay, so now the 4u squared, when we take it out, is going to be a 2u. We tack on the square root of 3. In the denominator, we have a t that comes out of the radical, and we tack on the square root of t. We still have one problem. After all that, we have a radical in the denominator. So we're going to multiply by 1 in the form of square root of t over square root of t. So I'm just going to put that 1 right here since we are out of room. Square root of t over square root of t. So in the numerator, that's going to become a 2u square root of. Remember that what's in the square root gets multiplied with what's in the square root already. So we get a 3t over here. And in the denominator, we have the square root of t and the square root of t multiplied to give me a t times a t, which is a t squared. Okay, so that's the end of that problem. So we will just put that answer right up here. Okay, I'm just going to put it right here. And put 2u square root of 3t all over t squared. And then we'll erase all of this and do our last problem here. So we've got the cubic root, and there's no reason to keep these together at all, okay? So we've got the cubic root, square root of n cubed over the square root of 2m to the 5th. Now, I don't want to rationalize this thing right now because it's not simplified yet. So let's go ahead and break this up into perfect and leftover. So 2 is a leftover. It's not a perfect square. M to the 4 n times m. Okay, so the numerator can also be split up. Square root of n squared is perfect and square root of n left over. Okay, so now the n squared, square root of n squared becomes an n. And the square root of m to the 4th becomes an m squared. And then I've still got to deal with this right here. Okay, so let me get another board here. We'll just finish this one up on this board. So we've got n over m squared and we have the square root of n over the square root of 2m. So this is what we had right now. Right here, this is where we are. And when we look at that, we say, oh, we've got to multiply by a radical 1. We've got to multiply by the square root of 2m in the form of 1. So let's just do that right here. And we get the square root of 2m. Just ignore that right there. That's a different problem. Okay, so we multiply by the square root of 2m over the square root of 2m. So now what do we have? N is out, and the square root of 2m times the square root of n is going to be the square root of 2mn. And then on the bottom, the 2 square roots of 2m become a 2m times an m squared. So we get a 2m cubed, and nothing can cancel. So here's the first part of that problem. So we'll put them all up here. Okay, so this is the last part of that problem so that you can see all of that together. So now I will be back in a minute with some new boards and some new problems. All right, so we have 5 more boards of radicals, and then we'll be done with all of chapter 9. So on this one, we're talking about simplification. And again, on this one, notice that we can do something between the 35 and the 7 and the r cubed and the r to the 5th. So this would be one to use our quotient rule on to get them back together into one big radical. And again, whether you do this on paper, whether you do this in your mind, doesn't really matter. The fact is that you put these together. So we've got 35 divided by 7 is 5, and r cubed divided by r to the 5th is going to wind up with an r squared on the bottom. We wind it with a 3 minus 5, negative 2, and r to the negative 2 goes downstairs. And then, because my benefit of having them together is now finished, I'm going to put them in 2 separate radicals. So now the square root of r squared is just r, and my answer is square root of 5 over r, and nothing else has to be done to that one. In the denominator, I do have some things that I could do if I put them back together again. So I'm going to go ahead and take this and put them in one big radical. So now 8 and 12 will cancel. So 8 divided by 12 can reduce to 2/3. And the c cubed and the c will cancel with a c squared. And then I end up with a d on the bottom. So now my benefit for having them together is over. And I will go put it into 2 different radicals now. Okay, so they're separated now. And so now I've got the job. I have still got a c that I can pull out that I need to do in a minute, but I'm going to deal with my denominator first. And I'm going to make that multiplied by the square root of 3d, so I always have to multiply by 1 to get rid of my radical in the denominator. So now the square root of 3d and the square root of 3d multiplied together gives me a 3d. In the numerator, I wind up with a 2 times 3, or a square root of 6 c squared d. C squared d, okay, 6c squared d, but I still have one problem, and that is that the c squared can come out. So when I break that one up into a perfect radical and a leftover radical, my 6 is left over, my c squared is perfect, and my d is left over, okay? So this c will simplify, this will simplify to a c. Square root of c squared becomes a c, and I end up with c square root of 6d. So we're just going to pull this one out and put c times the square root of 6d. And since nothing can cancel, none of the outside things can cancel, and remember, something inside the radical cannot cancel with something outside the radical. All right, so here we're putting two radicals together, two radicals that have fractions in them. So we're going to use the product rule and possibly the quotient rule to get these simplified. Now, again, I can see that if I put these together in one radical using my product rule, that I would get something that would cancel. So 3 times 1 over 10 times 6. So I'm just putting them all together under one radical. And you can see now that the 3 and the 6 will cancel with the 2. And I wind up with a 1 over 20. So now I'm going to break it up. Square root of 1 over square root of 20. And square root of 20 can simplify. So let's bring the rest of this problem down. We're going to break, square root of 1 is just 1. Square root of 20 can break into a perfect and a leftover radical. So the perfect is 4, the leftover is 5, the square root of 4 is 2. So we put a 2 there. And we still have a radical in the denominator. So we need to multiply by 1 in the form of square root of 5 over square root of 5. So I'm just going to do that in the front here since we're already over to the right of our board. Square root of 5 over the square root of 5. And now my answer is going to be square root of 5 on the top. Square root of 5 times 1. The square root of 5 times the other square root of 5 will give me 5 times 2 is 10. And I cannot simplify that. That is my final answer. So I'm going to go ahead and put that answer right here. Since you saw me do it, square root of 5 over 10. Because I need this part for the next problem. Okay, so now in this one, I've got a square root of 5, square root of 8, 1, 3. You know, nothing's going to cancel. So I'm just going to go ahead and multiply them together and say that's going to be the square root of 5 over the square root of 24. The square root of 24, when I multiply those together, is going to give me a square root of 4, square root of 6 when I break it apart. And that's going to become a 2 square root of 6. So we'll make this a 2. And then the square root of 6 is offending one of our simplification rules. We cannot have radicals in the denominator. So I'm going to multiply by square root of 6 over the square root of 6. So once I simplify, then it's much easier to multiply by 1 in the form of the simplified radical portion, because then I don't have as much to simplify at the end. So now square root of 5 times square root of 6 is square root of 30. The square root of 6 times the square root of 6 gives me 6 times 2 is 12. And 30 as a square root has nothing that I can pull out. There are no perfect squares in 30. So for the last 3 problems, we're going to be rationalizing the numerator. Some higher math classes will have you do this for certain applications. So basically, we're doing the same thing that we've been doing for the denominator, but now we're trying to get rid of the radical in the numerator. Like I say, you don't see this very much, but occasionally. So we're going to multiply by the conjugate. Since we're trying to get rid of the radical up here, we're going to multiply by the conjugate of the numerator. So that's going to be 6 square root of 5 plus 8. 6 square root of 5 plus 8. So we always multiply by conjugates when we have 2 terms. So now, remember, when we multiply by conjugates, we get a squared minus b squared. So it's going to be the first term squared, which is going to be 36 times 5. And 36 times 5 is 180. Okay, and then we're going to have minus the last term squared. All right, and then the denominator is going to be 2 times 6 squared root of 5 is 12 squared root of 5 plus 16. Okay, so the numerator is now going to be 116 over 12 squared root of 5 plus 16. And if we divide everything by 4, then the numerator is going to become 25 plus 4, 29. 29 over, divide by 4, 3 squared root of 5 plus 4. Okay, now I did enough of that in my head that I'm going to try to check that answer and see what it was. Okay, so okay, so I think we got that one right. All right, so we're going to do this problem, and we're going to simplify. Now, this is the same problem we just did. In the last problem, we rationalized the numerator. Now, we're going to just simplify like a normal radical, okay? So, this one is, if we just were leaving it with the numerator clean of any radicals, then notice that I have a 6 and an 8 and a 2. So I should factor out of the numerator a 2, and I'll get 3 square root of 5 minus 4. And then this one's already factored in the denominator. And then my answer will be the 3 square root of 5 minus 4. Okay, so that was what I was supposed to do with that last problem. But I thought it was a rationalize the numerator type of a problem, but this is really what they wanted us to do. But you could have a rationalize the numerator problem just like that one, so I went ahead and did it both ways. All right, so this one is going to be the same thing. We're just simplifying. We are not rationalizing the numerator, but there is a factor that we should pull out, and there's also a perfect square underneath the radical that we should take out. So we're going to go ahead and break up the 50. Remember, square root of 50 is square root of 25 times the square root of 2. So the 50 will simplify to 5 square root of 2. So we will end up with 15 minus 5 square root of 2 over 10. Now notice that everything will divide by a 5. So we're going to factor a 5 out of the numerator and get 3 minus square root of 2 left over. We're going to factor a 5 out of the denominator and get a 2 left over. These will cancel. So now we have this right here is our leftover 3 minus the square root of 2 over 2. Get rid of the rest of that. And the last problem in chapter 9, and again, this one is a simplify. So we're going to first break out our square root of 27 is the same thing as the square root of 9 square root of 3, or 3 square root of 3. So let's go ahead. I'm tired. Let's just change this to 3 square root of 3. Now I have a 3, 3, 3 in each one of those. So if I pull out a 3, I get a negative 6 minus square root of 3 all over 3 times 5. Since I've pulled a 3 out as a factor, I can divide by 3, and now the entire expression is simplified. And we'll get rid of these 3's because they're gone, and we end up with negative 6 minus square root of 3 over 5. We don't need those parentheses anymore. And that is the last problem on 9.6. And the last problem needed to prepare you for the Chapter 5 test, or the Test 5. Remember that 9.7 and 9.8 will be put on the final exam. We are getting so close to being done with this class. So, this is Mrs. A, and may God bless your day.